I'm attempting to repair this Mimi 801 vintage computer. So far in this series I've gone through repairing the case, had a few minor issues with the power supply which are now corrected, and I've also had some intermittent issues with the interconnect wires between the power supply and the main board. Most likely I'll be replacing the connectors. They're fairly badly oxidized and corroded, so they're not making reliable contact. Same issues with some of the ICs. The pins are very badly oxidized, and so some will need to be removed and cleaned. They are all in sockets, and in this case that might work against us because this type of socket are fairly notorious for causing issues with bad contacts, and the contacts are not really accessible to be cleaned, so that may cause us some headaches later on. In the previous video in this series we got as far as having a look at the output signal of the video connector, and we did appear to be getting something sensible. So what we'll do to start in this video is just really for a bit of fun, although this technique can be quite useful sometimes, is we'll see if we can figure out what is coming out of the connector before we hook up a monitor. You can waste an awful lot of time trying to go straight to hooking up a monitor if you're not getting sensible signals coming out of the output connector. It's composite video coming out of this machine, or should be, and if the signal's not correct then a lot of monitors will tend to misbehave, and like I said, you can waste a lot of time trying to figure out what's going on. So we'll start by looking at the signal, see if we can figure out what's coming out of the machine. We'll make a few assumptions to start with. So what I normally do is start with a simple grid, make an assumption. In this case I'm making the assumption that it uses a 7x5 character set, and the reason I'm making that assumption is because when we looked at the signal coming out we could see that 7 consecutive lines had some data and then the following lines had nothing. That tends to indicate that that's either part of a larger character or it's a full height 7 line or 7-bit high character. Also with this type of machine from this era they quite often used 7x5 pixel characters, and so that's what I'm going to start off by assuming. We can always come back and modify this if it turns out not to be the case, but we have to start somewhere. So what I will do is subdivide this into 5 pixel wide groups. Now between each character we'll most likely be getting a single pixel space, so I will again make that assumption. So this will just be a space, that will be a space, another space. So I'm just going to do the last 3 characters that appear to be on the line, simply because I think I know what they might be, and this will be a good way of confirming this. So first thing is we need to capture some data, so I'm just going to move the camera so you can see the scope screen. And the next thing is we'll power up the machine, and we can indeed see there is some data. It's composite out, so about 500 millivolts per division should be about right, which it is. Quite a lot of jitter of course, because the nature of this signal means it's not going to trigger that reliably. We can't really trigger on the sync pulses because otherwise we'd be getting just kind of random lines, and we want to trigger on the lines that are showing some actual data. So what I'm going to do is set up the scope so we can hopefully capture those 7 lines of data. So do a single capture, and we have captured some data. So what we can do now is zoom into the individual lines and see what information is there. So I've got the vertical cursor lines set to 470 nanoseconds separation, and the reason I've chosen 470 nanoseconds, the duration of each line, from what we're picking up on this, appears to be somewhere, if we zoom right out, this is the high part of this signal, it appears to be somewhere in the region of about 57 microseconds. And if we work out what we think is the number of pixels for each character and the number of characters per line, the duration of each character should be somewhere in the region of 470 nanoseconds. So by setting the vertical cursors to 470 nanoseconds, then what we're doing is assuming that anything that fits within those two cursors is a single character. So what we can do now is start looking at these last three characters for each line. So we'll start off with the first of those three, and what we are assuming here is that we'll have a character, a space, which will always be a low signal, and then the next character. So if we look at the two characters at the start, we can see that the only way we can really fit this into the cursor lines is to do a character like that, and then the next one will be like that, and that will leave a space between the two. And in terms of the information there, again, if we make the assumption there are 5 pixels across each character, then what we have, and what we can put onto our little diagram here, is 3 pixels for the first character. Move across to the next one, 3 for the next, and the pixel at each end, the first and last pixel, are blank. And then if again we leave a space for this blank pixel, that brings us to about there, and that means that we have a single pixel there. What we can do is move on to the next line, and then we can do the same thing again and bring it to the last 3 characters that we are interested in. So what we have now is the first character, the first and last pixel seem to be a 1, and on the next the first and last seem to be a 1, and also the one just before the last pixel seems to be a 1. And then if we go across to the next, then what we end up with is that appears to be a 1, and that appears to be a 1. I'll do the rest. I'll do the rest off camera. I don't want to get you too bored. I'll do the same thing with the remaining 5 lines, and we'll see what we end up with on the paper. Once we've done all of the 7 lines, we end up with this information, and hopefully you can see it seems to say 801, and I am assuming that the start of the text, that's this bit, would spell out the word Mimi. So I think the data that's been put out of the video port is going to show us Mimi 801 if we connect a monitor. So that's the next thing we'll do. We'll get a monitor hooked up. Before we go straight to a full-size monitor, I'm just going to use the small monitor that I've shown in previous videos. Just a very small monitor. You won't be able to see the screen very well, but it will give us an indication as to, firstly, whether what's coming out is what we expect, and also if it's working at all correctly. So we'll get that monitor set up and see what happens. I have the test monitor set up. It's powered from the bench supply. It is currently powered up, but there's nothing showing on the display. The computer is turned off. I have the input to the monitor connected to the video out of the computer, so we'll try and switch it on, see what happens. So you want me to see this very clearly. I'm just going to dim the lights and hopefully you'll be able to see this a bit better. Turn off the other lights. Unfortunately my camera doesn't seem to like this monitor, so it might be a bit on the blurred side, but I can read this and it's saying MIMI 801, which is what we were expecting. More importantly, it is getting as far as outputting text, and it's doing that in a fairly stable manner. So it's looking good so far. We are getting some data coming out of the computer. Don't know how well the rest of it's working. I'm a bit concerned the PIO is completely cold. It's not doing anything at all. Might just be a poor connection to it. So the next thing I want to do really is have a look at the disk drives. Now I'm not refurbishing or restoring this machine, I'm just trying to get it working, so I'm just doing the minimal amount to try and get it to boot up and run. So the next thing I'm going to do is I'll clear off the bench and we'll get the disk drives, have a quick look at them, make sure that in all things being equal they should work, and then we'll hook those up to the MIMI. We'll do the same with the keyboard, get that hooked up, and we'll go from there. So this is kind of a different approach from what I quite often show. I'm not really going through everything in a lot of detail. I'm just taking the shortest route I can from the machine arriving to getting it running. Having said that, I am going to replace these connectors. They are causing issues again, and I can see that there's fluctuation on the power supply that really we need to deal with, just to make sure it doesn't do any damage. Power supplies dropping out on vintage machines like this can damage ICs, so the next step, get the connectors replaced and then have a look at the disk drives. I've replaced the connectors on the power supply. The old ones were they were tarnished and oxidized. I've taken a few of the contacts out, and it's probably hard to see on the camera. This one's not too bad, but if we look at some of the other ones, we get another one, we can see it is fairly badly tarnished, and the two contact areas on some of them were really bad. Also they tend to get fairly poor contacts where they're crimped. It's not really crimped, it's actually just the wires pushed into this slot, and these metal strips cut through the insulation of the wire, and the conductors are supposed to make contact with each side of the slot, but over the years it's got some corrosion in there, and it's making poor contact, and as I move the wires around, sometimes it makes contact, other times it doesn't. So I've replaced those. I've fitted it with a few of the more modern Molex type connectors, crimped these on. These are properly crimped to the wires, so it should make much better contact, and also the working resistance should be lower. So we can now turn our attention to the two floppy drives. This is under restoration. It's just trying to get the machine functional again, so it's really doing the minimum amount possible to get it to behave itself and do what it's supposed to. I believe one of these drives has been replaced because these don't match the different variants of the drives. Very similar, but there are some small differences between these types. So what I'll be looking at here is whether these will turn. And this is turning, but it is tight. This one is also turning, but again it's tight. The motors seem fine, so I'm assuming it's just hasn't been used for a long time. So what I'll do, I'll take the bearings out, clean them, lubricate them, and that should free them up. The motors should be fine. So we've got the motor here that drives the disc, spins it round. Actually a bit noisy, but hopefully that will clean up. And then we have the stepper motor that operates the head. So this should move fairly freely, and it's moving, but it's very sticky. You can probably hear the noise it's making. So we'll clean the two guides. Same with this one. In fact, this one won't move, so that will need to be taken out and freed off. And also, if I turn this round, So if I recall, one of these had a missing stop, so it's that one. These are upside down, so it makes it sound worse than it actually is, but there should be a stop so you don't get metal to metal contact. They're loud anyway, but they shouldn't sound like that. So I'll get these cleaned up, and while I'm working on these I will also clean up the keyboard. It's absolutely filthy. Hopefully it will work, but it just needs a good clean, so I'll get that done at the same time. I'm just going to put this in the ultrasonic bath. These switches are fine as long as you do completely dry them out as soon as you've cleaned it. Don't leave it sitting with water in there for any length of time. It will ruin the switches. So this should clean out. Also, make sure when you put it in a bath it's upside down. If you run it the wrong way up, all the dirt that you free off will end up inside the switches and make things far worse. Okay, so I'll get this done, get these sorted out, and then we can reassemble everything and see if it actually works. So a quick look inside this. I've removed the plate off the top. There's normally a cover that sits on the top of this, and I have of course unscrewed the PCB. And what we're trying to clean up here are these guides. You can see the guides here are absolutely filthy, and you can take these out. There's a screw at the back and a little clamp that holds it in place, and there's one at the front. You only need to take one or the other out. It's usually easiest to take the one out of the back. You can then slide those out and give them a good clean, and so that's what I will probably do here. It depends how well they free up. And then we need to clean the read-write head. So this is a double-sided drive, so there's a read-write head on the top and there's another one on the bottom, and all we need to do is very carefully clean the heads which are sitting between these two. So there's one at the bottom there, and then there's one on the underside of this. And what we need is for this to move back and forth very freely. If it's squeaking or sticking, then it's not going to work properly. This is the one that wouldn't move. It is now moving, but it's still too tight. Sometimes you need to lubricate the motor bearings. I advise you don't disconnect this. There's kind of a strap drive here, and if you take this off, then you'll have problems realigning it and getting the head to properly track on the disc. So it's best to not take this off if you can avoid it. Usually taking out the guide rails and giving them a good clean is all that's required. So that's what I'll do here to start with, and then we'll of course clean the rest of the drive up. I've cleaned up the two drives. I've dismantled them, cleaned the guides, cleaned up the bearings. They're still a bit tight, but they do now rotate quite freely, and they don't make the noise that they did. The heads are now free to slide back and forth quite freely. Haven't tested these yet. I haven't tried powering them up. So what we'll do now is plug everything together and see what happens. If these are even partially working, then when we power them up, they should reset the head. If we manually move it away from the home position, the head should return to the home position on both drives. So these are now up to the point where I'm going to reattach everything. I've also recrimped this cable. You may recall that it was falling apart, so I've recrimped that. While I was cleaning the drives, I also spent a bit of time and cleaned up the keyboard. It was filthy, and had a couple of broken parts. In particular, the space key had broken off, so I fixed that. Again, I don't know if this works yet. All I've done so far really is clean it up. So next thing, we'll get it all connected up, power up the system and see what it does. I've got most of it connected up. I've left the two interface cables disconnected. They don't go anywhere anyway, and in theory it should boot up, but I suspect it's not going to. There's an awful lot of oxidation on the pins of a lot of these ICs, so I suspect this is not going to work straight away, but we'll power it up, see what it does. We'll see if the drives reset, and we'll go from there. At the moment I've got the cable disconnected, so I'm not expecting them to do very much. I just want to make sure that there's nothing that is going to fail in a catastrophic way. We just want to start small steps and see what this does. Okay, well the power light's come on, which is a reasonably good sign. No other sign of activity on here. The monitor's come back to life. You probably can't see this, but next thing is we'll try pressing a key. Okay, we have to take my word for it, it's not doing anything. I didn't really expect it to, and the drives didn't reset either. So we'll try getting the drives reconnected through the ribbon cable. I think someone's been tinkering with this. I noticed that the heads on the two drives are reversed, so they're not wired the same way. They'll work, but effectively the two heads will be flipped over on the two drives. I don't know if someone's done that intentionally, but it's something we may have to come back and address later on. This is one of the things when you get an old machine with an unknown history. You can find that some things don't work quite the way they're supposed to. So next thing up, I need to try and bring this back to life. We'll plug the drives in and see where that gets us. I've got the drive ribbon cable plugged in. We'll power the system back up. The motors have started up. We'll see if they stop. They should stop in a few seconds if it's working at all, which they have. I'm just going to try resetting the system to see if the motors start back up. And they do, so it's partly working. I suspect we're not getting all the control signals going through the way they should, either because of dirty connections or there's a fault with the devices that are trying to drive them. What I'm going to start off by doing is swapping these two devices over. These are responsible for quite a lot of the interface, and then if that doesn't work we'll try a new PI. There's really, it's quite a simple system. Z80 system, of course. It's quite simple, and most of the interfacing is done through some fairly simple in-out devices. So I'll swap these over, clean the pins, and we'll see if that gets us any further. It's actually about 3 weeks later now, and I've been working on this on and off throughout that period, and this has been causing a lot of problems. It's had, I don't know how many faults, and they mostly seem to come down to corrosion of the sockets, the IC pins, and also for some reason most of the ICs seem to have degraded. I've mentioned this in previous videos that occasionally you'll get ICs where the outputs aren't giving the level that's required to drive the rest of the system. And this has been a very bad example of that. I've had, I think about 25 of the ICs have caused that sort of problem. There's also a strange mixture of 7.4 series families on this board. So we've got HC, LS and S versions, but they all seem to have the same date code. So I think they were put in the factory, at least most of them. Some do seem to have been changed, but I think the majority are the originals, and that's usually a bit of a red flag. It means they were probably struggling to get the timing correct to make this run properly in the first place. A lot of the devices do tend to run hot, and again I think the timing on this is generally not that good, and I think that's really what's causing most of the problems. And basically nothing on this worked. Initially the screen came up, but that was all that was working. Nothing else on this would work at all, and unfortunately I'm getting to the point with this where I can't really justify spending much more time on it. And I've dealt with most of the issues that it's reasonable for me to deal with. This is not my machine. Normally a machine like this would take 3 or 4 hours to repair. I've spent close on 100 hours on this already, and the faults have mostly come down to, I've had a few broken tracks on the board, but the rest of it, what it really needs is all the sockets changing. They're all taking it in turn to cause problems, and I don't think this machine will ever be reliable without the sockets being replaced. So I'll just very quickly go over what I've found so far, what I've been correcting. The first thing I did, following on from the first half of this video, was to try and get the keyboard working. If you recall, I press the key, nothing would happen on the screen. And if we look at the screen now, I'll just turn the lights off so you can hopefully see this a bit more clearly. It is now getting much further. And I can also press a key and you will see it is responding. Now on top of this, I've also got the monitor program up and running, so if I want to look at a memory location, for example, I can do that. So we'll look at memory location 0. Now you probably can't see this on the screen, this is obviously just a very small test monitor, but I can also modify the value. So we'll change this value to 14, the next address will change to 15, and then we'll go back and look at the values that are now in memory at those addresses. So we'll go back to 0, and although you probably can't see it, it's saying 14, and the next address is saying 15. So I can now read and write the RAM successfully. Let's turn the lights back on. Let's move the camera across and explain the problem we had with the keyboard. So the keyboard on this machine uses a fairly interesting device. It's one of these, it's a KR3600, and these are it's defined as a read-only memory, a ROM, but it's actually a keyboard ROM and scanning device. So what it does is you feed it with a clock, or it has got its own internal clock if you want to use that, and then it will output strobe signals onto column and row, and it will read each of the columns and rows intersections to see if any of the keys are being pressed. And it's got all the required decoding. It's also got inputs for control and shift, and what it actually outputs is a generic scan code. So it's not a scan code in as much, it's not an ASCII scan code, that sort of thing, but it is a scan code that you can then feed through to a ROM, which is how most of these systems are configured. So we have a ROM on the keyboard, so the generic scan code comes out of the scanning controller, and that's fed into the address lines of the character ROM, and the character ROM contains whatever character set you require. So it converts the generic scan code from the controller into, in this case it's an ASCII, 7-bit ASCII code. And this wasn't running at all. There was nothing coming out of the driver lines. I thought it was faulty at first, but then I realized the internal clock wasn't running, and it was configured to use an external clock. That wasn't running either. So I fixed that. That was actually just a shorted tantalum cap. So I replaced that. That brought the keyboard mostly to life, but I had a few faulty keys. Still 2 keys on there here that don't work, the 9 and the 6. The actual keys work, but it's not providing a scan code. Kind of strange. I suspect it might be one of the inputs to the keyboard controller is faulty. The rest of the keys seem to work, so I don't know exactly how this is arranged. I don't have schematics or technical documentation for this machine, and but that got the keyboard up and running. It then started to output characters. Let's move the camera back across. But the next problem I had, although the keyboard was outputting characters, there was still nothing appearing on the screen of the CRT. And eventually traced that down to some timing in the multiplexers for the RAM, and it basically wasn't switching between the RAM and the ROM properly. So this the RAM's divided into 4 blocks of 16K. The block on the left here is the video RAM. The block on the right is the RAM starting at 0 and going up. And because this system uses it's kind of a generic version of CP/M, so that gives us a lot of clues as to what will be organised where, and indeed I found I could write characters to screen memory. So that was all working, got that working, and the next fault I had was it was constantly going around a tight loop trying to read data from the serial port, and that turned out to be a faulty 1488. So and that's kind of how things continued. It went on, and every single time I took a small step forward, sure enough there was another fault. And so it's got to the point now where I'm getting as far as it trying to read the floppy disk. I'm going to turn the lights off. So if I try and get it to boot by pressing the B key, so as you can see, it's going through the process, but it can't see the disk. Turn the light back on. So I suspect there's a problem in the control circuit for the disk drives. Could be the drives themselves. I have tried swapping them over, but that didn't make any difference. There is something very strange in this machine. I don't know if someone's been tinkering with it, but on one of the drives, the heads are swapped over, so the top and bottom head connections have been reversed. So I don't know if that was intentional, but obviously it would cause some odd behaviour of the machine if you swap disks from one drive to the other. Don't think that's what's causing this particular fault, but as I say, I'm getting to the point now where I can't really justify spending too much more time on this. I'll probably spend a bit of time looking into the floppy drive issue, seeing if it's something fairly straightforward. But what I've advised the owner to do is to just swap, if he really wants this to work, swap all the sockets. If you flex this board, it's not as bad as it was, but if you flex the board, quite often the machine will crash, and it's just the ICs aren't making good contact with the pins in the sockets. Other than that, it does seem to be getting close to the point where it's going to work. It just now needs a few hours invested to get it finished off. But probably in the last video in this series, I'll just go through the floppy drive control circuit. As I say, I don't have a schematic for this. If anyone's got one, I'd appreciate a copy. But in the next video, I'll go through the floppy drive control circuit and see if we can't get at least some activity out of that. But this is just one of those basket cases that really has taken far more time than it should have done. But it's all part of the fun of playing with these vintage machines.